Hello, so now we're going to go over balancing redox reactions, and these reactions you balance them either under acidic condition or basic condition, and they will tell you whether it's acidic or basic either explicitly by saying it's balanced under acidic condition or basic condition, or implicitly because you look and you have an acid that's reacting in the reaction, or you have a base that's a reactant in the reaction, excuse me. So you have to balance these reactions systematically. And so those are the 8 steps. So first we're going to go over balancing under acidic condition, then we're going to go over balancing under basic condition, which is just an extension of balancing under acidic condition in terms of the methodology. So first you need to break up the reaction into two half reactions. One of them will be the oxidation half reaction, the other one the reduction half reaction. You don't need to know which is which as long as you break them up in a manner that makes sense, and I'll go over what that is in a few minutes. Then you balance all elements except oxygen and hydrogen. Then you balance oxygen by adding water, balance hydrogen by adding hydrogen ion, balance charge by adding electrons. Then you equalize the number of electrons on both sides before adding the two equations together. Then simplify if needed, and then check to make sure everything is balanced, including charge. So equalize the number of electrons on both sides, reactant and product, before adding the two equations. I'll go over what that means. So in order to make sense out of these rules, let's actually apply them, because it's the application of them that's important, that you need to know how to do. So I'm going to go over here and do this example for you. So that's the reaction between dichromate ion plus copper in presence of hydrogen ions. It's under acidic condition. So sometimes they may have the water and the hydrogen ion here, sometimes they may not. You don't need to worry about those at the beginning. You can just ignore them. And so if they didn't have water and the hydrogen ion, they may just say here, for example, acidic condition. So I need to break this up. The first rule says break it up into two half reactions. That makes sense. So by that, what I mean is dichromate should go with chromium. You shouldn't write dichromate going into copper. That doesn't make any sense. And then, of course, copper goes into copper 2 ion. And again, for now, hydrogen and water, hydrogen ion and water, don't worry about, ignore those. So then balance everything except oxygen and hydrogen. So 2 CRs, 2 chromiums here, 1. So I have to put a 2 here to balance the chromium. Here, 1 Cu, 1 Cu, so that's balanced. 7 oxygens here, so I have to add 7 waters to this side to balance the oxygen. This one I don't need to worry about because there's no oxygen. Then to balance hydrogen, 7 times 2 is 14, so I have to add 14 hydrogen ions to that side. And then I balance charge by adding electron. This one's easy. This is 0, this is plus 2, so I have to add 2 electrons to make it 0. You always add the electron to the more positive charge, because you can lower the charge, you cannot raise it. So here I have 14 plus and 2 minus, so that means 12 plus on this side. 2 times 3, you multiply the coefficient by the charge, so 2 times 3 would be plus 6, just like I did here. 14 plus 1 is plus 14. So 2 times plus 3 is plus 6, so that's plus 6. This is 14 plus, so that's plus 12. Plus 6 plus 12, so I have to add 6 electrons to this side. So that's how you balance the charge. Again, before we do anything, let's make sure we did it correctly. 2 chromiums, 7 oxygens, 7 oxygens, 14 hydrogens, 14 hydrogens. 6 minus 14 plus 8 plus, 2 minus 6 plus, 2 times 3 is 6 plus. And then this one, 0, 0. Because it's 2 plus 2 minus is 0, and this is 0. So initially you don't need to know which is which one's the reduction reaction, half reaction, which one's the oxidation half reaction. But now you can figure it out. This must be the reduction half reaction because I'm adding electrons to it, so it's grabbing electron. So this must be my oxidizing agent. So this is the reduction half reaction. And this one must be the oxidation half reaction. It's losing electrons. Of course, you could have figured this out because copper is going to copper 2 plus stuff. But since electrons is on the product side, this must be the oxidation half reaction. Since electrons on the reactant side, it's grabbing electrons, that means. That is on the reactant side, so this must be the reduction half reaction. Now, before you add them, you need to equalize the charge on both sides. So, you know, again, earlier you can pause the video and write the rules down, but when I said equalize the charge before you add the two equations together, what I meant was in the final balanced equation, you don't want to have any electrons, so you want the electrons to cancel out. So I have 2 electrons here, 6 there, so I have to multiply this by 3. If I multiply it by 3, I get 6 electrons on this side, on the product side, 6 on the reactant side, they cancel each other out. If you're doing this and you end up electrons on the reactant side on both equations, or on both equations on the product side, that means you did something wrong. Because one of them should be, half reaction should be on the reactant, the other one product, or vice versa. So now I add these, so 6 electrons, they cancel out, so I can ignore the electrons, 14 hydrogens plus dichromate. And the electrons cancel out. So now I need to look and see if I need to simplify it. Sometimes you may have water on both sides or hydrogens on both sides, so you need to simplify it. In this case, I don't. So this is the balanced equation. I need to check to make sure everything is balanced. So 7 times 2, 14 hydrogens, 2 chromiums, 3 coppers, 3 coppers, 7 oxygens. The charge is also very important. So 2 times plus 3 is plus 6, 3 times plus 2 is plus 6, so that's plus 12 on this side. 14 plus minus 2 is plus 12 on that side, so the charge is also balanced. So this would be the net ionic equation. Remember, these are net ionic equations, that's why each side has an overall charge, because we're not showing the spectator ions. Next, we're going to go over balancing under basic condition. For basic condition, you basically do the same exact thing up to here, except in order to get rid of hydrogen ions, you're going to add hydroxide ions to both sides. So you're going to add enough hydroxide ions to both sides in order to get rid of the hydrogen. So I'm going to say under basic condition. Let me move the camera so you can see this. Hopefully this will upload and it's not too long. I'm going to do it quickly. So under basic condition, you need to follow steps 1 through 7 for balancing under acidic condition, and then add enough hydroxides to both sides. Remember, the equation's balanced now, so you can't add to just one side and not the other. So you add enough hydroxide to both sides in order to get rid of hydrogen ions. So here I have 14 hydrogen ions on the reactant side. If you rewind the video, you'll see. That means I have to add 14 hydroxide ions to both reactant and product side in order to get rid of that 14 hydrogen ions. How do I get rid of the hydrogen ions? You rewrite H plus OH minus as H2O, and then simplify if needed. And again, check to make sure everything's balanced. Including charge. So I'm going to do the example next because I'm afraid it will not upload.